All right, now it's time to put together the refrigeration cycle and how all these components work together. Before we do, let's just chat a little bit about the refrigerant metering device. And there are several different kinds that are outlined in your book. There's supplementary information about each one in detail. But what you do need to know is that it controls the flow of the subcooled liquid from the condenser going to the evaporator. And basically it is a restriction. And what that restriction does is like putting your thumb over the your hose, your garden hose. The pressure builds up behind, but then there's very low pressure after it sprays past your thumb. And that's what happens with a metering device is it takes the high pressure liquid refrigerant and drops the pressure down below its boiling point. And that's what starts to cause the heat transfer to happen in the evaporator coil. Now this is a diagram that comes from your book. It's got about a 3 or 4 page description of what we're looking at here, so we're going to break this down piece by piece. Let's blow it up just a bit. All right. So metering device. This just shows the restriction. This designates a metering device, whether it be a piston, fixed orifice, cap tube, or TXV. That's our metering device, and we're going to start right here. As the refrigerant leaves the metering device, it immediately flashes to approximately 25% vapor and 75% liquid. It's normal. It's what it's designed to do. Now, if you had your refrigeration gauges on the system, this system in particular, you're going to have you're reading 69 psig, and this is an R22 system, by the way. And if you could get your thermometer into the evaporator coil and clamp it on there, it's going to read 40 degrees Fahrenheit. And you can verify this by taking a look at the pressure temperature chart for R22. So here's our R22 pressure temperature chart. We are at 69 psig, which is right about here, which brings us right between the 40 and 41 degree mark on the refrigeration pressure temperature chart. So that's how we know that it's 40 degrees. Anytime you put your gauges on, that's how you're going to be able to tell what the temperature of the refrigerant is. Now, the one thing to remember when we are talking about the pressure temperature chart, and I've said this before, but it bears saying again, the pressure temperature chart only works when the refrigerant is in its saturated temperature and at saturation temperature and pressures. So that only refers to from this point to this point in the evaporator. Once everything is boiled off, all the refrigerant is boiled off, it's no longer in its saturated state, and it does not have any correlation to the pressure temperature chart on the other page. So don't forget that. This is when it's in this, when we're talking about the pressure temperature chart and refrigerant, that means it's in the saturated state. That's where if you add heat, in this case in the evaporator, it's going to change state from liquid to vapor. All right, let's follow this around. So at this point we're at 75% liquid and 25% vapor. The indoor fan is blowing the return air across the coil. That's what this designates right here. And the refrigerant is flowing through here, and as it does, it's boiling off down through the evaporator coil. And as it gets down here to 0.4, we're about 50-50 at this point. So we're still in the saturated state, but we've given up a lot of heat to this refrigerant. And if you could put your thermometer on there again, it's still 40 degrees because it's in the saturated state. It's 68 psig. We know it's 48 degrees in the coil. So the refrigerant continues down through the coil. It's boiling, 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 changing state from liquid to vapor. And the coil is designed so that as we get to near the end of the coil, all the refrigerant is boiled off before it leaves the coil, and at that point we're starting to pick up superheat, and we drop off the pressure temperature chart that we looked at earlier. And now we have just refrigerant in the vapor state, and so it can't change state anymore. So any heat that's added to this is called sensible heat. And now if you put your thermometer down here on the refrigeration line, you're going to see that you can measure now 50 degrees Fahrenheit. And when it was in the saturated state, it was 40 degrees Fahrenheit. Now, at this point, we know that the refrigerant is all the way boiled off. It's gained as much heat as it can gain, and it's gained 10 degrees of superheat. That's the difference between the saturation temperature and that line set refrigeration line temperature where it leaves the evaporator coil. This is designed in the system to make sure that no liquid gets back to the compressor.